In this tutorial, we'll be dealing with the deformation of objects. As an example, we'll be deforming a cylinder, which is something that could be used to depict a hydraulic hose, for example. We begin by creating a cylinder. The length of the cylinder should be split into several subdivisions. We then orientate it along the z-axis. It is important that we use the Modify Freeze Transformation option to freeze our cylinder in place. This means that the values for translation and rotation must then be set to 0 and the scale value to 1. Now we can switch to the Animation tab. Here we'll find the Joint tool. Double-clicking on this symbol not only activates it, but also opens its settings dialog. For our current objects, we only need to minimally adjust the options. For the moment, the option Orient Joint to World provides us with all the settings we need. We'll now create 3 joints. To make sure the joints are in a straight line, we can specify their exact position in the Attributes editor. After that, we can then move the joints into the middle of the cylinder. This is essential as the resulting deformation is highly dependent on where the joints sit in relation to the object. The next step is to connect the joints to the object. To do this, we first select the cylinder and then the joints. Then we go to the menu and click Skin, Smooth Bind, clicking on the small square next to it, so that we can set the options ourselves. In the options, we give max influences a value of 4. Then click on Bind Skin and we've created a deformable object. We can easily test this by changing the position of one of the joints. We can also rotate the joints. As we can see, the result of our deformation isn't always as appealing as we would hope. To make the deformation as accurate as possible, we can adjust the weight of the joints. This can be done with the help of a special tool found under Skin, Paint Skin Weights tool in the menu. If we select the cylinder in the scene graph, the color of the currently selected joint shows its weight. In the Paint Skin Weights tools panel, we can switch the currently selected joint. If we go through the joints, we can see that the effect of the first joint acts until the middle of the cylinder. The second joint acts from the middle to the end of the cylinder. And the last joint has only a slight effect on the end of the cylinder. We'll change this weighting now. First of all, we'll increase the weight of the middle joint in the first half of the cylinder. We set the painted weight to 1.0, select the middle joint, and then paint the specified value on the corresponding surfaces. Now we increase the weight of the third joint at the end of the cylinder by carefully selecting it and painting the surfaces at the end. Then we switch back to the normal selection mode for objects and select the middle joint. Using the Move tool, we shift the joint and see the effect the repositioning has on account of the newly set weights. By rotating the middle joint, we can also get a good look at the new distribution of weight. Before we can export our object into an i3D file, we'll need to order the objects and joints in the scene graph. The joints must be placed hierarchically above the object. Now we've done that, we can then bring up the i3D tools. We want to set the physical properties to none, as setting it as a physical object would prevent it from deforming. Now we can export our little test scene and open it with the Giants editor. In order to see more of our scene, we need to create a light first. If we've done everything right, the positional information of the cylinder will be set to 0, and we'll be able to deform it using the joints. Now we'll go back into Maya and have a look at a more complete model that includes a number of deformable objects. Here we have a liquid manure trailer with a drag hose, where the drag hose includes a number of joints to deform the individual hoses. Now we open up the model until we can select the group Arm Left Bottom Part 1. When we rotate this element, we can see how the hoses deform. Now let's look at the weight distribution. First, select the hoses. Then click on Skin, Paint Skin Weights tool in the menu, and now we can see the weight distribution. We see that we have the weight of one joint acting on the beginning and the end of each of the hoses. This ensures that the tube does not deform here. The actual bend in the center of the hose is a result of a change in the relative position of the central joints in relation to the other two joints.